Welcome back to lesson 1.1. We're going to start off with example 4, which is where we're going to talk about whether if a function is increasing or decreasing over a certain interval. So what that means, if a function is increasing, we're looking at what's happening to the y values as we go from left to right, okay, over all of the x values. So as I go from left to right, or as my x values are getting larger, what's happening to my y values? That's what's important. So on this particular graph, as we go from left to right, the y values are getting larger and larger. Okay, don't pay attention to the arrow. Even though it's pointing downward, we're looking at what's happening. As I get closer and closer to the y-axis, the y values are going up. They're increasing. Now, on the other side of the y-axis, as I continue on going over to the right, again, we're crossing this way. As we go to the right, the y values are now getting smaller and smaller. They're decreasing. Okay, so this is the graph of 2 minus absolute value of x. So the way that we would write out the intervals for increasing, we describe them by the x values. Okay, so it's increasing. This graph keeps on going, so there's no limit on the x values. So from negative infinity all the way to here, which is where my x value is 0, the graph is increasing. It's decreasing after that. So from 0 on to infinity, because again, this graph doesn't stop. It's going to keep on going because of the arrows on the end. So from 0 to infinity, this graph is decreasing. So maximums and minimums. The point at which the function changes from increasing to decreasing. Okay, so here it's increasing, then it's decreasing. That point is called a maximum. Where a function changes from decreasing to increasing, so let's say you had a U-shaped parabola. Here the graph is decreasing, then it increases. So where it changes from decreasing to increasing, this point is called a minimum. If it's a parabola, it's also called the vertex. So the graph that we were looking at has a maximum value of 2 at x equal to 1. That's this point right here. Okay, average rate of change. So what is the average rate of change of a function y equal to f of x, that's this function here, over the interval from a to b? So a and b are x values. Okay, so on the next page, here we go. Here's the points where x is a and where x is b. Now the y value is labeled in function notation. So it's called f of a, which remember, function notation is replacement for y. This means the y value when x is 1. F of b for this point means this is the y value when x is b, okay, whatever value that is. Okay, so the interval starts at f of a and it ends at a value of f of b. So what we're going to do to calculate the average rate of change is take the difference of those y values, okay, and that's what they're showing here. Here's the difference of the y values. If we create a right triangle, this side length would have the length of the difference of the two y values. This side length would have the difference of the two x values. Okay, what we're going to do for average rate of change is basically use our slope formula and calculate the slope. So if we take the difference of the y values, remember slope in general is x2 minus x1. I'm sorry, y2 minus y1 over x2 minus x1. And that's what you see here. The only difference is that instead of using y values, we're using it in function notation because we're going to have to calculate this. The points aren't going to be directly given to you. So the difference between the average rate of change formula and your regular slope formula is we use this when we know the coordinates, and we use this when we have to calculate a coordinate. So again, this is the same as the slope of the line between the points AF of A and BF of B. So what do the average rates of change over these intervals from -2 to 0, 0 to 3, and -2 to 3 indicate about the given functions? So these intervals, remember, these are all in terms of x values. So we're saying, what is this function doing from -2 to 0? What's its average rate of change? From 0 to 3, and from -2 to 3. We're going to look at those three intervals for each one of those functions. So notice here, this function is f of x equal to 1. Right? The graph of f of x equal to 1 or y equal to 1, it's this horizontal line. Next, we have g of x equal to 1/2 x minus 1. So we get this graph of a line. Right? So this is a linear function. And lastly, we have h of x equal to x squared, which gives us the graph of this parabola. So when we calculate the average rate of change for each one of those intervals, this is what it looks like. So for the first function, and you probably want to pause at this point, take a good look at all of the calculations so you can see where the numbers are coming from and how they're getting these end results. Okay, so I'll walk you through the first one. For -2 to 0, for our first function, if I look at -2, the y value is 1. When I look at where x is 0, the y value is 1. So f of -2 is 1. This is f of -2 minus f of 0. F of -2 is 1, f of 0 is 1, and then down here it's just the difference of these x coordinates. Okay, let's actually go over to this one so you can see the difference here. Okay, so again, I'm using those same values for x of 0 and -2. When I look at f of -2, that's this point here, the y value is -2. When I look at f of 0, the y value is -1. So here's that -1. Here's the -2. Okay, so again, that's f of, this time they did the reverse order of f of 0 minus f of 2. Or I'm sorry, f of -2. Okay, when we calculate that, we get -1 minus a -2, that's the same as -1 plus 2, which gives us 1. And then down in the bottom, it's just the difference of those y values. So actually this over here, I guess the values are the same. I think I wrote that out of order, so it should be f of 0 minus f of -2, which again doesn't change anything because it's still 1 and 1. Okay, for the last one here, again, we're using that same interval from -2 to 0. Looking at the y values, here's the 4, here's the 0. So again, they're starting with f of 0 minus f of 4. Okay, so the y value at 0 was 0. The y value, I'm sorry, oh my gosh, f of -2. The y value at 0 is 0. The y value at -2 is 4. And that's where these numbers are coming from. In the denominator, again, it's just the difference of the x values, 0, minus, and negative 2. So as the interval changes, notice the denominator. Those are always the same because we're doing the same interval for each problem. The y values, however, they're going to be different because each function is different. So again, pause the video, take a look at all the math here, make sure you can understand where the numbers are coming from, the numbers in the numerator and the numbers in the denominators. Okay, so now that you've had a good look at that, let's talk about the big question was, what do the average rates of change indicate about the functions? So notice here that for all the calculations, the average rate of change is 0. Okay, and that makes sense because, we're talking about slope. This is a horizontal line. The slope of a horizontal line is 0. Okay, so it does not have, the rate of change is 0, meaning it's constant, okay, throughout the function. For g of x equal to 1/2 x minus 1, notice how we always get 1/2 for the average rate of change. Again, this should make sense when you're talking about slope, because here's that slope of the line. Remember mx plus b? This is the m part. It's always 1/2 because this line doesn't change, its slope doesn't change. So this means that it's a linear function. For the last one, notice how we have different values. Over the first interval, we had negative 2. Over the next interval, the slope was 3. Over the next interval, the slope is 1. So when that happens, when it does not have a constant rate of change, okay, it means that it's a nonlinear function. In this case, it was a quadratic function. Okay, so that ends our lesson for the second part of 1.1. If you have any questions, remember you can always join me during the Zoom hours on Tuesday or Wednesday afternoons. Or if we have the time, you can ask me in class. Okay, but Zoom hours are always best because then we're not pressed for time. Okay, I'll see you soon.